up and running again, picking up where we left off yesterday. Talked about Maradona-like kicking the ball up in the air. Nice knuckle, straight up, straight down. Initial position was 0-3. Quadratic relationship, and I suppose, we talked about symmetry, so over here, after 4 seconds, it's back to 3, catching it on the foot. And that's the end of that experiment, but if the ball kept going, it's going to hit the floor, right, which is a height of 0. And if we have an equation, God, we can find that number pretty easily. And I think I said it took 2 seconds to hit a height of 67 feet, a nice canned situation here, so we can see the numbers working. And we're beginning to look at how to construct these quadratic relationships, how to numerically work with them, symbolically work with them. And so there's our vertex. And what do we have? We have movement back of -2 units on the x-axis to get to 0, because symmetry, the pattern, numerical pattern emanates from this location. I hope you can intuitively see why. And so if I went from 2 to 0, well, that's really -2 units change, but quadratics, when we square -2 times -2, we get 4 units of change. And I don't want to move up 4 units because up 4 units doesn't take me to 67. So I get rid of that 4 units of change. And what I really want is change from 67 to 3, which is -64. That's a nice number again, right? So my height as a function of time, we might as well bring in t instead of x, just to change things up a little bit. So height as a function of time, time being seconds, is determined by -60. Well, I haven't done it out yet. -16 t minus 2 squared plus 67. And on day 1, we said the origins of this discipline are rectangular. Now, obviously, somebody didn't draw a rectangle as the first mathematical moment on planet Earth, but so much of everything we do comes from that relationship. It's foundational. So we got to play with some rectangles here, especially with this construction. So let's play with some rectangles here. Let's start with something we know. I think we know that 3 times 4 is 12. Let's look at it rectangularly, because this could be length times width equals area. I think that's probably one of the most famous products in the world. And of course, we can change that to rate times time equals distance, which has a lot to do with things like this that you might see later in your life. Rate times time equals distance. Okay, I took a little poetic license there. All right, liberty. So 3, let's call this 1 unit. Let's just say that that's 1 unit. And let's get 2 more, that's twice that size. And let's look at construction here, 1 unit. And let's get something 3 times that size. And let's just look at that area, which has to be 12. 3 times 4. Well, we got a 1 times 1. We got a 3 times 1. We got a 1 times 2. And we got a 2 times 3, which is really, if I break this up into that kind of construction, let's see, where am I at here? 6 units, right? So we got 6 units. 1 plus 3 is 4, 2 plus 6 is 8, 4 plus 8 is 12. Hopefully you can see that that's true. So this is called the length, 1 plus 2. This is the width, 1 plus 3. Mechanically, that has to equal 12. 3 times 4 equals 12. We can see that that is true. So how does that happen? Well, the distributive property, really, on steroids. We've got 1, this number, times 1 plus 3, which is what I did. 1 times 1 plus 3, there it is right there. And then we have 2 times 1 plus 3, and that's the lower part here. 2 times 1 plus 3. And people in this business like to call that foiling. So 1 times 1 is 1, 1 times 3 is 3, and 2 times 1 is 2, and 2 times 3 is 6. And if you look at that, I'm not going to take time, but I'm sure you can see that that adds up to 12. All right, so now let's go to the abstract. Let's look at a new situation. Let's look at x plus 4 times x plus 5. Okay, I've got x, which could be any distance. And I got an x here because I've got x squared. There it is. There's x squared. And then I'm going to add, let's make the top x plus 5. And let's say that this is 5 units. All right, each one of these is 1. Okay, so I've got x times 5. So I know that's 5x. And where does it come from? Remember, 1, 1, 1, 1, 1. That's an x. 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 Those look like terms to me. And here I have 4. 1, 2, 3, 4. Oh, I got a quadratic. I got a 4-sided figure. Quad, Latin for 4. And each of these is 1, 1, 1, 1, but we're going to say 4 over here. And so what do I have? I actually have 1 times x, which is this, another 1x, another 1x, and another 1x. And I think you need to see this. And I got 4 times 5. So I got, oh, nice. This is nice now that I have this, right? And I think if you count those squares up, you're going to get 20. So what do I have? Well, I can see x squared. I can see 1, 2, 3, 4, 5, 6, 7, 8, 9 x's. And I can see 20. And you take a good hard look at that. And I think you'll see some patterns. So I hope you do. I hope the numbers speak for themselves. I hope I don't have to say anything. Because if I don't have to say anything, you're actually being a mathematician now. You're analyzing something and looking for patterns. And if I don't say anything and you figure something out, then you just had some mathematical thought processes occurring in your cerebellum. I don't know if that's true or not. Maybe there's different cerebellum. Anyway, whole nother discussion. All right, so where am I going with that? Oh yeah, we're going back to what we're looking at, which is this kick the ball up in the air problem. Remember, I got the ball 3 feet high. Can't get my leg up anymore. Maybe I can a little bit better. Boom, straight up after 2 seconds, maximum height, comes back down. Okay, so we're looking at h of t equals minus 16, t minus 2 squared. And you go ahead and do t minus 2 times t minus 2. You can do that out sometime on your own. You'll be doing it every day anyway. Plus 67. I'm just going to take the shortcut. I know I'm squaring that. I know I'm going to get double that product. Well, I might as well show it. You're just learning this. Can you see that I've got minus 2 times t and another minus 2 times t in that foiling process? So whatever that product is, I'm going to double it. And then I'm going to square the last term. And then I'm going to add 67. And if I take my time with that, then h of t is equal to minus 16t squared plus 64t. Minus 16 times 4 is minus 64. Minus 64 plus 67 is 3. Oh, where have I seen that number before? Oh yeah, that was the initial condition. Right, that's where it was. I shouldn't draw that part because the ball was stationary. Although I think we can intuit that this is a parabola, and we said that 4 gets us 3 because of the symmetry. We can check that out. Let's put a 4 in. 4 minus 2, 2 squared 4. What's minus 16 times 4 plus 67? Yeah, that's 3. Take my word for it. So what is this 64? We talked about it briefly yesterday. It was actually the force of the ball, the initial force I put on the ball, which means that, honestly, that means I can write the equation of a line right here. At that instant, if I zoom in, I've got 64 times x, t, I'm doing t minus 0 plus 3. Sorry, I'm not writing that. but that's the initial force. And up here, the rate of change is 0. Well, that makes sense because the ball seems to, by Air Jordan, just stop before it starts coming down. I don't know why it came down. Oh yeah, I guess it's the force of gravity, which we'll look at in more detail later. So this actually tells me something about the physics of what we're looking at. Of course, it's not written in meters, which the rest of the world is working with, but that's okay. So moving on from here, the whole purpose of this was to look at, oops, I gotta move the computer here. I don't want to have to start all over again. I do that too many times. So we're basically trying to get a better understanding of this critter. And I am suggesting that that is the most important thing that you take into that brain of yours and start to think about. Minus b over 2a. So let's actually look at what that is. But before we do that, let's go back to this. So this was a very important time. This was a very important time. So the question is, do you think you can find out what that one is if you didn't have it displayed? Hopefully, yes. Hopefully you would say, oh, it's between, we talked about axis of symmetry. It's between these values, 0 and 4. That's how we can get that, if we have that information. What if we didn't have this information? How do we get that? This is how you get it. So let's look at it. First, we have this minus 16t squared plus 64t plus 3. Okay, minus b. Well, b is 64, so I'm doing minus 64 over what? 2 times negative 16, which happens to be minus 64 over minus 32, and lo and behold, we have very easily found the most important x, we usually work in terms of x, value of a quadratic. Not hard to do. And if I have that most important value, then I can sketch a quadratic extremely easily. Now, I think I missed something. I want to look at this from a different perspective right now, from the perspective of products. Rather unconventional way, right, of doing this. Now, I haven't shown you yet why I can do that. And there's a real important geometric lecture that I've got to give you. And not right now, no need to do it right now. You're just trying to build some skill. So let's look at this from a slightly different perspective, from the product perspective. Minus 16t squared is a product. It's minus 16 times t squared. We talked about products yesterday. I think I asked somebody what was 7.387 times 4.96. And I don't think anybody in the class could do it. Shame on you. But then I said, well, can you do 7.387 times 0? Well, gosh, yes. Of course you can, right? This class is based on zeros. And what? And ones. Okay, that's what we're doing in every conversion that we've only been at this 2 days, right? We're already marching along pretty well here. So let's actually look at that from the perspective of products. Here's products right here, those first 2 terms. I have minus 16 times t squared, which is a product. I have 64 times t, which is a product. And I have plus 3 way out here. And one thing we want to learn in math is how to rewrite things. And we're actually beginning to do that. We're beginning to look at how do you write this sum as a product. And I've only said it a couple of times thus far, I think twice. I like to keep track of how many times I say things. Okay, and I'm going to say it again. I'm going to ask you the question. What's the first rule in writing products? I don't think anybody's going to say what the first rule is, but maybe somebody does. And it is take out what's common. So let's look at this. Minus 16 times t plus 64 times t. I'll take a moment, ask yourself, what's common there? I think t is. So let's write this in that fashion. Oh, and you know what? 16 actually goes into 64 because 64 is 4 times 4 times 4, 4 cubed. And there's your 16 times 4. So I can actually take minus 16t out and do what we were doing over there a minute ago, that foiling process. And so minus 16t times what gives you minus 16t squared? Obviously t. And minus 16 times what gets you 64? Actually, it's minus 4. Okay, so minus 4 times minus 16 gets us a positive 64. All right, so let's look at h of t. I'm going to erase this a little bit. But I'm going to erase this. All right, always do that. And let's look at writing h of t in this fashion. And left, got to get more space. H of t, height as a function of time, can now be written this way. All right, and I'll write it above here just to see that you're trying to learn how to do some of these things. Minus 16t squared plus 64t plus 3. Take a moment to look at that. I hope you can see that that's true. And coming back to this concept of 7.38 times 0, okay, and even taking it a step further, length times width equals area. Guess I got to talk about that for a minute. Let's take length times width equals 20. Can you tell me what numbers I used? Probably right now, some of you said 4 times 5. You'd be right, that's 20. Some of the rest of you might have said 2 times 10. Maybe somebody could have said 1 times 20. All of those things equal 20. So does x times 20 over x. And I could put Joan of Arc in here. Oh, that doesn't sound good. This brings back. Never mind. Poor images. All right, but cancels and you get 20. So there's an infinite number of ways to write the product equaling 20. But as soon as I drop that 2, we're in a whole nother world. If length times width equals 0, then either length equals 0 or width equals 0. It has to be true. One of those has to be true. And we're at that right now. We're at length times width plus 3. We got that. Length, width. All right, so what numbers make that 0? Well, I got to have one of the factors. Notice I used the word factor now, and I hadn't used it before. I don't like to use the word factor because when I ask students what factoring is, I don't get too many responses. That makes sense. It's not easy to talk about mathematics. So I prefer to say turning sums and differences into products for a while. And I've just done that. This was a sum. This is now a product. All right, so let's highlight that product. Keep going around the room. Let's keep going around the room. And I would hope that we could look at this and say, okay, it's a negative 16t squared, cup shape down. Okay, and what makes length minus 16t squared? I'm sorry, just t, that was one of the factors. Width t minus 4. Can you tell me what makes this product equal 0? 2 times. When t is 0, 0 times negative 16 is 0, and 0 times anything is 0, and 4. And if I make this function plus 3, well, then that's going to get me 0, 3, and 4, 3. And if I've got those two numbers, then the average of those two symmetric values, 0 plus 4, cut in half, gets me that 2. Seems to be true. And it looks like my camera's a little fuzzy here, but oh Lord. God, let's see if it improves. Yes. Okay, we're gonna live with it. All right, which means that now I can sketch quadratics pretty darn easily. So let's try one. And then we'll practice them the rest of the term. Generally speaking, there are shortcuts to everything in life, but let's look at 2x squared plus 20x, and let's do plus 3. Because we know that this is a cup shape up. I know that 0, 3. I know that 0, 3 is on the increasing side, and I will show you why at some point. But right now I know it's on that side, but let's pretend we don't know. So I now know my x value is going to be negative here. Right, but how do I find the x value? Minus b over 2a. Okay, we'll pretend we don't know that right now, but these are products, right? So what number do we want to plug in to make that a 0? Obviously 0. If I put a 0 here, boom, those go, and that gives me 3. But 2x squared plus 20x plus 3, 2x squared plus 20x plus 3. Where's the most important part of this discussion? The vertex. How can I find that quickly and easily? Minus b over 2a gets me that x value. In this case, it's minus 20 over 2 times 2 is 4. I now know this is negative 5. I can plug negative 5 in for x because that's going to tell me the y that I get. What I've got an equation already. I'm just trying to rewrite it. Let me get this a little shorter. So what do we now know? We know that that's x plus 5 squared is how we want to write it because we're at a minimum. And the minimum area of a square is boom, boom, 0. Right? I can keep making, and I want this to act like 0 times 0. All right, so when I put negative 5 in, I get my 0 times 0, my minimum. All right, now I'm going to put negative 5 in quickly. Negative 5 times 20, 100 minus 100. I know that's got to be 50 plus 3 because there's this nice 2-to-1 ratio. I probably should have let you find that out for yourself. Minus 50 plus 3 gets me minus 47. And yeah, I know 0 gets me 3. Anytime you want to find a y-intercept, and so that's, that's my, somewhere in here's my origin. Right? Anytime you want to find a y-intercept, plug 0 into the calculation. You'll hear me say that every day for the rest of the term. Okay, do I have this centered well enough? All right, so it's easier to sketch and then write in graphic form. So what do I have here? I can take the 2. I can take it. Right, it's right. It's handed to me. I need right now. I have x squared. I need 2 of them. Well, I hope that makes sense. And also, I now know what happens when I put a negative 5 in. I get minus 47. Now, how do we do this from scratch? Let's say we don't have any of this. Well, we see that and we go, oh, well, then that's x plus 5 squared minus 47. And then if I go over 5 units, I should go up 25 when I square, but I don't go up 25. I actually go from negative 47 to 3, which is 50. And then you can see that multiplication by 2 from a different perspective. All right, so I'll do one more for you quickly here. Sketching. Let's try a negative this time. Let's do minus 3x squared. Let's look at minus 3x squared. Let's look at how about 12x plus 12x, and how about plus 7. All right, so what do you know? What do I know? I know it's cup shaped down. I know I want to do minus 12 over 2 times negative 3. Well, that's minus 12 over minus 6. That tells me that's a 2. That's helpful. I'll throw a 2 in and see what comes out when I throw a 2 in. 2 times 2 squared, you square before you multiply. 4 times negative 3 is negative 12. That means without looking, the next one should be 24. Oh yes, 2 times 12 is 24, plus 7. I can cut this number in half because minus 12 plus 24 is 12, and 12 plus 7 is 19. Boom. Now I just need the y-intercept. I need one more point so that I have an accurate graph. Okay, how do I find the y-intercept? You heard it again. You throw a 0 in. You get 7, and 0's to the left. On the increasing side, where do I know that? Right there. That second term tells me that. All right, so there are quicker ways to get this, and we will develop them, but that's pretty quick. And if you can learn that, you're in great shape. You don't have to look at all those shortcuts unless you like, examining things like that. All right, so that's the end of this lecture. I don't know how long it took, but whatever, it's something you needed to hear and get started on. And so on your worksheet today, you're going to put a quadratic in graphing form. Hopefully get some success with it within the next couple of weeks, where you look at it and you go, oh, I can do that. All right, and bye-bye.